Okay. What's your name?
Good afternoon. My name is Amako Anthony Ichuku. I'm a foreign level mechatronics student with the Federal University of Technology, Owerri.
So why are you here?
I'm here to present a project that we did for this semester. It is an automatic changeover system.
Oh, okay. Which course is that?
This is for MC 413.
Okay. Tell us how this work. This is the project. So come and tell us what the project is doing.
Okay, so basically we have the power supply coming in from here. So when it gets to here, um, these are all circuit breakers. Then this is the switch or the outlet in the house, and this is also a switch to control the bulb or the lights. Then for the circuit breakers, first of all, the power supply will go in through here and to pass through first the current circuit breaker. This one is able to accommodate a large current of up to 1600 amperes. So the current or power supply will also pass from here down to the residual current circuit breaker. So this is basically just a protective circuit breaker. It helps to prevent against electric current or electric shock in case there's any short circuit or any leakage. Then from here now we have next the high voltage circuit breaker. So it basically serves as a voltage regulator. It helps to ensure a steady voltage of 230 volts, as you can see here on the house. Then next we have the earth leakage circuit breaker. So this is also another protective circuit breaker. So basically it also helps to avoid electric shock and also to redirect lightning current in case there's a lightning. Then after this we now have the next component or the final component, which is the miniature circuit breakers. So this now we have like about three and four of them rather. So each of them have their ratings. So basically, if we are connecting a lower load, we can connect it to the 15 amps circuit breaker. Then for a higher load, like maybe your electric iron or maybe your heater, you can connect it to the 30 amperes. So in a case where for this one now, if the current exceeds 15 amperes, it will cut off. But this one can accommodate up to 30 amperes, which is suitable for heavy loads. Then next is now the main switch. So this is just used to control or to turn off everything or turn on everything. Then after this, we now have the sockets and the switch, which is used to control the bulb. And that's basically everything.
So basically, this is exactly what is obtainable in a residential building.
Exactly, yes, sir.
Okay. Who among you has something to add to what he has already said? Who among you has something to add? You don't want to talk? Eh? Yeah, I said it all. Okay. So, what else did you learn in your 413? Tell us your name. Come here.
My name is Supervised.
Okay.
Also learned how to program the basic circuits for street lighting that in such a way that when it's day it will turn on, when it's day it will switch off, and when it's night it will automatically turn on. That is without human input. And also when it detects motion, when someone is coming close, it will turn on so that the person can see them. When the person leaves, that's after a set time, it's then switch back off. Then we learned the code that is used to program the Arduino and the circuit arrangements for the street lights system.
Okay. Do you two men have talked now? So, tell us your name.
Okay, I'm Ogota Isemajoy, Mechatronics Department, 100 level. Concerning the automated street lights, there were two basic sensors that were used. The LDR, light dependent, the LDR resistor, and the PIR, that's the passive infrared resistor. The passive infrared resistor detects motion. That is, so whenever it senses motion, it blinks. then turns off. Why the LDR detects light intensity usually with resistance. The higher the intensity, if there is increase in it, I mean if the intensity is high, the resistance is low, and vice versa. That's how it switches. So the both of them were incorporated to build the automated street light, such that the LDR detects when it is day, like when there is light. If there is light in the day, that means it's going to turn off. Then maybe when it's night, the resistance will be very low. Resistance will be very high because there is no light and the light is going to come up. But for the passive infrared light, the passive infrared resist sensor, it now detects motion. So it was incorporated in such a way that when there is, if it is night, the street light is going to come on. If it is daytime, to turn on. But when there is a motion detected or someone is passing, the light will blink in such a way that the person will be able to see whether it's day or night. So it can work both ways. That's technically what.
Okay. So how many days did you attend the training? You? Okay.
We attended, okay, my name is Ekene Samuel Mbonu, the 400 level student of Mechatronics Engineering. We attended the training in Thursdays in 4 weeks.
Okay.
So the practical runs for 4 times.
4 times.
That's once in a week, throughout in a month.
Okay. From what time to what time per day?
We stayed for a good number of time, from 10 till 4.
Till 4. Who were your instructors or lecturers?
Okay, one of my best instructor was Engineer Ekene Mbonu, and also Engineer Engr. Also, he took us on institutions.
Is it Henry? Who knows his name?
Mr. Owerri Pascal.
Sorry, oh, Pastor. Okay. Is he a staff of Futo?
No, sir.
He came from outside, but an expert. Is that correct? So what is the correct name of your second instructor? It's okay. So what do you think we should have done better to improve this training? One person.
I think what should have done better to improve the training is.
Tell us your name.
My name is Ekene Samuel Mbonu. I'm a student of Mechatronics Engineering.
Okay.
Yes, and what we should have done better is to give more days for classes,
Okay.
and then more hands-on practicals, tools and things that we have facilitated us making by ourselves some certain things.
Okay.
Yes, sir.
Okay. So, what you are saying that we should incorporate it for the coming people.
Yes, sir.
But you did automatic light by yourself. You implemented it here. It's okay. Okay. Who else has something to say? What do you think we should have done to make the training better?
So I feel like we should have, if our finances were more, each person was meant to have their own, we should have done it individually. That way we would have learned more. It would be better, everybody to their own set. You'll be able to, you just have to plan yourself and discover how your own must work, each person individually. So next time I feel like if we are more financially buoyant, we should do it ourselves.
Okay. You people didn't contribute
Yes,
much. So that is it. The original plan was for you to buy this thing yourself, do it by yourself, but then the finances. But I think it was
nice.
it was explained enough.
Yes, sir. Very well. Yes, sir.
It was explained enough. Okay.